Welcome to qnawire.
For this problem, we are given two very large non-conductive plastic sheets, each of 10 centimeters thick. And we know we are given the values for each of the charge densities in their surface, in their surface. These are called sigma 1, sigma 2, sigma 3, and sigma 4 with these given values. So we need to find the magnitude and direction of the electric field at some given points. And the procedure that we are going to follow is that we are going to compress the left slab with the right slab in each of the points so that we get a uniform charge density, and then add them and find the electric field, magnitude, and direction. So to do this, we need first to remember what is the electric field for an infinite plane. So to recall this, we can obtain the electric field through Gauss law. The Gauss law tells us that the closed integral of the product between the vector of the electric field times a differential of area of a vector area is equal to the enclosed charge over epsilon 0. So to get an idea of what is this, we're just going to draw. Suppose this is an infinite plane that is, or sheet, as you want to call it, that is positive charge. So to obtain the electric field, we use the Gauss law. The Gauss law tells us that we need to use a Gaussian surface, a Gaussian surface. In this case, we will use a cylindrical Gaussian geometry because it is the more convenient. So in this here, we will have that because the sheet in this case have a positive charge, the electric field is upward. So we will have an electric field for this. And in the front and in the back is also upward. So this is the electric field. Then the electric field is passing through this surface of the Gaussian geometry, so that this in here corresponds to a vector perpendicular to the Gaussian surface. So we obtain that the probability of that is just these two vectors are parallel to each other. So from this, we obtain that this is simply the electric field doesn't change, and this is the integral of the area. So we know that the integral of the area is just the area. So we obtain the electric field times the area. If this is equal to the enclosed charge over epsilon 0, which is the vacuum permissivity. Now, we just simply solve for the electric field, and this will give us the following. We note that in this case, we are counting this area and the one at the back. So we have 2 times that area. And we know that the sigma surface charge density is equal to the charge over the area. So in this case, we will obtain that this is the density charge over 2 times epsilon 0. So with this in mind, we can use this to obtain in our sheets the electric field at any position, at any point we want to measure the electric field. So for part A of this problem, we are asked at point A, which is 5 centimeters from the left face of the left-hand sheet. So the position is in here. We will have our sheet, and this is the point where we want to measure the electric field. So as I said in the beginning, we are going to compress the left slant with the right slant to get a uniform charge density, and then we add them to find the electric field. So if we just slam the all these surfaces of the sheets into just one plane, we will have that this will contain, as we are gonna call it, just like the total surface charge density will be, because in here we just need to think that this in here is negative charge, this in here is positive, this is also positive, and this also positive. So the electric field, when the surface is negative charge, it's inward. Meanwhile, that for a positive surface, the the electric field is outward. This also happens for this and this too. So in this case, we will have that we need to multiply the first one, um, surface density charge minus the other ones, and this is our net surface density charge. With this in mind, we can simply put all of the values that we know in here. So we know that sigma 1 it's minus 6 with this minus in here. The negative sign cancels, so we have sigma for sigma 2 we have minus 5 micro coulombs over meter square minus sigma 3, which is 2, and minus 4. So we would obtain a value of -5 microcoulombs over meter square. Now, sorry, as we found in the beginning of this problem, the electric field is this expression is the total, in this case, the total surface surface density charge over 2 times the vacuum permissivity. So we'll obtain that this is equal to sigma over 2 times epsilon 2, and the value of the sigma is 5 microcoulombs meter square over 2 times epsilon 0. Epsilon 0 has a value of 8.85 times 10 to the minus 12 Fermi per meter. So in this case, we will have that the magnitude of the electric field is 2.82 times 10 to the 5 newtons over coulombs. And we can see that from here we obtained that it is with direction to the left. So it is pointing to the left. Pointing to the left. Now, for part B of this problem, we do something similar, but the point of measure is 1.25 centimeters from the inner surface of the right-hand sheet. So in this case, we will have the point just closer to the inner surface of the right-hand sheet. So in this case, we need again to just transform this into something like, in this case, we compress these two and these two, and we just then add them. So we will have something like this. Two infinite planes, one in one side and one on the other. So in here, and again, we know that this is negative, this is positive, positive. So in here, we know that for this is pointing to the left, from this is pointing to the right, from this is pointing to the left, and from this is pointing also to the left. The electric field tau that is produced by each of these surfaces. So, having that in mind, we just going to zoom in here. We know that for the right one, we have sigma 1 plus sigma 2, and for the left hand sheet, we have sigma 3 plus sigma 4. And then we will have that in here. We will set that this is, we'll call this net 1. So net 1 is sigma 1 plus sigma 2. Knowing that values, we know that is minus 1 microcoulombs over meter squared. And for the net 2, the sigma net 2, we will have that in this case it is negative because it is pointing to the left. So we will have this. And this is equal to minus 6 microcoulombs per meter squared. Now, having all of this, we just simply need to sum all of this into the equation for the electric field. So we will have net minus the net of this second one. In this case, plus, in this case 2 over epsilon 0. So we will have that this is 7 microcoulomb meter U over 2 times 8.85 times 12 farads per meter. And this is 3.95 times 10 to the 5 newtons per coulomb. And it is pointing to the left again because we could see that the resulting surface charge, surface density charge, is most of them are pointing to the left, so we will have a negative electric field pointing to the left. Now, for the final question, we are asked the electric field in the point C that is in the middle of the right-hand sheet. So we will have the sheet and we will have a point C in the middle of the right-hand sheet. So again, we will try to slap all of this and just the four surface is going to be along. So we will have that in here of this form. So this in here, the left one, it's going to be sigma 1 plus sigma 2 plus sigma 3. Sigma net 1 is equal to sigma 1 plus sigma 2 plus sigma 3. And this in here will be just sigma 4. So we obtain that net sigma surface density area, which is sigma 1 plus sigma 2 plus sigma 3. So having those values, we know that that is minus 6 plus 5. That will give us minus 1 plus 2. That will give us a positive number of 1 sigma Coulomb per meter square. And in the expression for the electric field, we will have this net force plus the force that is in here. But in this case, we know that since this is a positive, this is a positive surface, we will have an electric field in this direction, and the other ones, this is positive, 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 this is positive, 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 and we saw that that has a positive direction, so that the direction of this is to the right, and the direction produced by the right hand sheet is positive, so it is in the negative direction. So we just need to rest this sigma. So this over 2 times epsilon 0. So we will have in here 1 squared minus the sigma 4, which is 4 microcoulombs per meter squared. And this again by sigma 0, which is this value. And from here we obtained a value of 1.69 times 10 to the 5 newtons per coulomb. And again, it is pointing to the left because the resultant, this resulting quantity of the surface density charge is negative, so that the direction of the electric field is pointing to the left, to the negative